So this is showing for each focal what seedlings are more likely. So this is total number of seedlings. This is focal tree. Beech is blue. Maple is red. So for here, we can say what? So what does this part of our graph show us? Come on, wake up. Wake up, wake up. What is this saying? Or what does this look like it's saying? What? Speak up, speak up. Right. So under beech focals with this data, it looks like we have a lot more beech seedlings than maple seedlings, okay? So for this one, what does this look like? Same thing, right? For our maple focal tree, we have a lot more beech seedlings than maple seedlings, okay? And then, again, you're going to go back through Vasterstats. You're going to put in this data for that website, but now we're just going to have 2 columns and 2 rows, but you're still going to record the chi-square test and all of that. The chi-square value, the p-value, and degrees of freedom. Okay? I do want to mention that there are before we go any further, there are 2 different types of chi-square tests that you can run. And the reason why we have you put your information into contingency table and we run a contingency test is because a chi-square test is trying to decide if your observed data is different from your expected distribution of data, okay? But for our analysis and for our stuff, we have no idea at this point what our expected distribution is, right? We have no idea what to expect when we go out into that forest. We just don't know. We don't know what we should be seeing and if it's different from what we are seeing. So if we did know, if for some reason we were out there the previous year and so we had our results from our previous year and so we had an expected distribution, then we could do what is called a chi-square test for heterogeneity. So all that means is that we know what our expected values are, our expected outcomes are. But for this, we do not know. So that's why we do the contingency table. So when you're putting that info into Vasterstats, that's going to actually be giving you, it's going to be calculating your expected outcome for you. There is a way to do that by hand, but again, I don't want to suffer through it, and neither do you. Okay? I just wanted to make that point that there are those 2 different things, and that's why we're telling you to do a contingency test instead of a test for heterogeneity. Any questions about that? Are you all glazing over? I apologize. I know this isn't that fun. Yeah?
Can you post these up on PDF files so we don't miss a table?
That I can probably do. Yeah. So I can probably do this with PDF. Do you have a question? That was your question? Okay. Yeah, I can probably post this as a PDF. I just, somebody asked me if I was going to post the entire Excel file, and that's not going to work because all you have to do is put your stuff in, and everything's done for you already, which is good for you, but I was up until 1 a.m. doing this, so it's not good for me. Okay? All right, so moving on, we put this information into our Vasterstats program, and now we have a chi-square. We can decide if our p-value is significant and therefore rejecting our null hypothesis. If we got a significant p-value here with this distribution, if we went back and saw this, what could we say? So if this is our chart, what could we possibly say about what part of this is significant?
The maples has quantity over volume.
Okay, we can probably say that, but what are we just looking at here? The fact that there are more beech seedlings under both the beech and the focal, or beech focal and maple focal, than maple seedlings, right? So just by looking at this, we can see that maybe the beech are, in this particular instance, they are having more saplings in the old growth forest than the maple. And it's not species specific. And so there's, where are we? Oh, so one of the questions is reciprocal replacement, self-replacement, and random replacement. So if it's reciprocal replacement, what we would see is that underneath a beech focal, there will be more maple seedlings, right? Because it's going to be the opposite. But right now, what we're seeing is more or less self-replacement. So, or I'm sorry, we're seeing self-replacement for the beech, but we're seeing maple reciprocal replacement, right? Does that make sense? Okay. I know this sucks, guys. I'm sorry. All right, so we're moving on to step 6. We're almost done. Okay, so now we're moving on to step 6. Again, this is our old growth forest, but now what we want to know is only distance to, or I'm sorry, instead of distance to nearest neighbor, what we want to know is the species of the nearest neighbor. And so this isn't exactly easy to represent. When you have your data sheet, this is going to be referencing exercise 1, step 1 through 3. So what you have down there for your canopy beech, your canopy maple, is the species of the nearest neighbor. But the way to represent that in Excel, an easy way to do that, is to just say for beech 1, you've got these two options. What is it? So for beech 1, we don't have another beech, but we have a maple. So that's just the way to numerically represent that information, okay?